welcome to this GCSE Science revision video for core physics on the EM spectrum. The EM spectrum, communications, expanding universe and redshift, and the Big Bang. Visible light is just one type of electromagnetic radiation. There are many other types of electromagnetic wave radiation. The shortest being radio waves, then microwaves, then infrared radiation, then visible light, then ultraviolet, X-rays, and finally with the shortest wavelength being gamma rays. The shorter the wavelength, the more energy the wave carries, so therefore the more dangerous it is. All objects give out and take in thermal radiation, which is also called infrared radiation. The hotter an object is, the more infrared radiation it emits. Very hot objects may glow, such as heating elements in a toaster or an electric fire. Other hot objects may not glow, such as iron. Some surfaces are better at absorbing and some are better at reflecting infrared radiation. Black surfaces are good absorbers, while shiny surfaces are good reflectors. Microwaves cannot be seen, but they can cause burns if they are absorbed by the body tissues. Microwave ovens rely on the ability of microwaves to penetrate about 1 centimeter into food. They are absorbed by water in the food, causing it to warm up. Microwaves go through plastics and glass, but can be reflected by metals. Radio waves are used to transmit television and radio programs. Television uses higher frequencies than radio. A radio receiver does not need to be directly in view of the transmitter to receive radio signals. Diffraction allows low-frequency radio waves to be received behind hills, although repeater stations are often used to improve the quality of signals. The lowest frequency radio waves are also reflected from the electrically charged layer of the upper atmosphere called the ionosphere. This means that they can still reach receivers that are not in line of sight because of the curvature of the Earth. Visible light is the light that we can see. It allows us to communicate with one another through books, hand signals and videos. Ultraviolet radiation is found naturally in sunlight. We cannot see or feel ultraviolet radiation, but our skin responds to it by turning darker. This happens in an attempt to reduce the amount of ultraviolet radiation that reaches deeper skin tissues. Darker skins absorb more ultraviolet light, so less of the ultraviolet radiation reaches deep tissues. This is important because ultraviolet radiation can cause normal cells to become cancerous. Ultraviolet radiation is used in sunbeds, security pens, and fluorescent lights. X-rays are one type of electromagnetic radiation. They are commonly used in hospitals to photograph bones, which they can check for breakages. X-rays penetrate less denser matter such as skin and body tissue, but not bone. They have a range of frequencies. They leave an image on photographic paper, so more dense areas in our bodies such as bone allow fewer X-rays through, so appear paler on the X-ray image. Less dense areas such as skin and many tissues allow X-rays through. Gamma waves have a high frequency. Gamma radiation can not be seen or felt. It mostly passes through skin and soft tissue, but some of it is absorbed by cells. Gamma radiation is used among other things for the following purposes: It can be used to sterilize surgical instruments, to kill harmful bacteria in food, or to kill cancer cells. Radio waves, microwaves, visible light, and infrared radiation can be used for communication. Radio waves are used to transmit television and radio programs around the world. A radio transmitter can refract things or diffract radio waves at lower frequencies, whereas microwaves used in transmitting TV shows have to be passed up to a satellite in the Earth's orbit, where it can then be transmitted back down to get around the curvature of the Earth. Microwaves can also be used to transmit signals in this way. Mobile phones and mobile phone receivers use microwaves. The universe is expanding. There is a range of evidence for this. The first piece of evidence is redshift. When an object moves away from an observer, the light is affected by the Doppler effect. Our sun contains helium. We know this because there are black lines in the spectra from the sun where the helium has been absorbed by the light. These lines from the absorbed spectra of helium are shown on the left-hand side. When we look at spectra from a distant star, we still see an absorption spectrum. However, the pattern of the lines has moved towards the red end of the spectrum, as you can see in the lower picture. The positions of the lines have changed because of the Doppler effect. Their wavelengths have increased as they've been stretched out because they're travelling from a star that's moving away from us. Astronomers have found that further from us a star is, the more its light is redshifted. This tells us that distant galaxies are moving away from us, and that the further away a galaxy is, the faster it's moving away. Since we cannot assume that we have a spherical place in the universe, this evidence generally explains that the universe must be expanding. Scientists have gathered a lot of information about the universe. They have used observations to develop a theory called the Big Bang. The theory states that about 13.7 billion years ago, all the matter in the universe was concentrated in a single incredibly small point. This began to enlarge rapidly in a hot explosion called the Big Bang. Scientists discovered that there are microwaves coming from every direction in space. The Big Bang theory says that the energy created at the beginning of the universe, just after the Big Bang, and that has been travelling through space ever since. Some of the other pieces of evidence for the Big Bang is that light is redshifted, so therefore the galaxy is moving away from us. So if we go back in time, then the galaxies must be moving closer together. The further a galaxy is away, the more the light is redshifted, and that if we map cosmic microwave background radiation, it comes from a roughly spherical hemisphere, suggesting that it all originated at a single point. Remember, when revising, start early, turn off distractions, keep asking yourself questions, and quality revision is better than quantity of revision. Good luck with your exam.